Which one of the following statement is true for this series? Options are: the series converges conditionally but not absolutely. The series converges absolutely. The sequence of partial sum of the series is bounded but not convergent. The sequence of partial sums of the series is unbounded. Means the sequence of partial sum is bounded or unbounded, and this series is convergent or absolutely convergent or conditionally convergent. We have to ask about these four things. Means first is, you can understand what is the meaning of conditionally convergent. Conditionally convergent, if this is the series minus 1 raised to the power n a n, if you can say this is the un for this series, if series un is convergent, but series mod of un is not convergent, then we say series is converges conditionally. If after making the positive terms of the series, as this is alternating series, if we make the terms of this series is positive, then if convergent, then we say series is absolutely convergent, because absolute values of the terms are making the series convergent. So we say absolutely convergent series, and absolutely convergent series means convergent series. So we are going to test this series is absolutely convergent or not. So this is un is minus 1 raised to the power n 2n factorial divided by n raised to the power 2n. This is the un of the series, and after making the positive terms, means mod of un will be 2n factorial upon n raised to the power 2n. This is a positive term series, you can say, means summation mod of un, and we can apply all tests for positive term series. As one of them is ratio test, and that says if limit of, suppose, an upon an plus 1, if an is the term of the series an plus 1, and this limit is greater than 1, we say by ratio test sequence is series is convergent, and if less than and equal to 1, then we say is divergent. So we are going to apply ratio test, because if terms are containing uh, factorial, then ratio test will help you to find convergence of the series. Or so we are going to find limit n tends to infinity, as after making the positive terms, so mod of un divided by mod of un plus 1, and what is the limit of this one is greater than or less than, so this one equal to limit n tends to infinity, and that one will be, as un is 2n factorial upon n raised to the power 2n, and this one will be n plus 1 raised to the power 2n plus 2 divided by 2n plus 2 factorial. Now we have to find the limit of this expression, and you can see this factorial will cancel out, and this is 2 more, so you can write 2n plus 2 and 2n plus 1, and after that this factorial having the term 2n factorial, this one is cancelled out by this numerator, and this one is cancelled out by 2n, when you can take n as a common from this term, as n raised to the power 2n plus 2, and this one will be 1 upon 1 plus 1 upon n raised to the power 2n plus 2. So this 2n will cancel out by this one, and we will have n square in numerator. So finally, what expression we have? Limit n tends to infinity n square 1 plus 1 upon n raised to the power 2n plus 2, and in denominator 2n plus 2, and this is 2n plus 1. If you didn't get to the how I wrote this, so you can do your calculation yourself. Or you can understand better how we solve this. So you can take n as a common from this first factor, and then n is also. So this n will cancel out and we will obtain limit n tends to infinity, and this one is 1 plus 1 upon n raised to the power 2n plus 2, and we have 2 plus 2 upon n and 2 plus 2 upon n. Numerator part we can write, or this expression can be written as a limit n tends to infinity 1 plus 1 upon n raised to the power 2 and 1 plus 1 upon n raised to the power 2n. So this is of the form 1 raised to the power infinity. So you can apply L'Hopital rule in this, and 2 plus 2 upon n, and second bracket is 2 plus, I think this one will be 2 plus 1 upon n. So this is, so value of this one is 1 plus fx raised to the power gx, and directly we have the formula or idea what is the limit of this expression, as limit of gx is going to infinity, means 1 raised to the power infinity type. So limit will be limit fx into gx, and limit of this one e raised to the power this, so e square. So we have limit in numerator, because of this limit is going to be 1, so 1 into e square divided by 2 into 2 into 2, so this is e square upon 4, and we know that value of e is 2.718. 2.718 means around 3. So e square is approximately 9 upon 4, and this value is greater than 1. So by ratio test we obtaining limit is greater than 1. This means that series is convergent absolutely, and absolutely means convergent. So option B is true, and absolutely convergent, but option C not absolutely, so this is false. S series is absolutely convergent, means convergent, and every convergent sequence of partial sum is bounded. But here is given the sequence of partial sum of the series is bounded but not convergent. So this is again false statement. The sequence of partial sum of the series is unbounded. This is again false. So you can understand if the sequence of partial sum is bounded, then it may not be necessary that the series is convergent. You can consider 1 minus 1 raised to the power n this series, or in expanded form you can write 1 minus 1 minus 1 plus 1, or if this is going to be from 0, so means alternative positive or negative, so 1 minus 1 plus 1 minus 1. Sequence of partial sum is bounded, but this series is not convergent. If all terms of the sequence is positive, and sequence of partial sum is bounded, then series most of the case is convergent, or I think finally convergent, not most of the case, final it will be convergent. So keep remember some points of the absolutely convergent and boundedness of the sequence of partial sum to discard the options for this time bound problem.